So we've talked about what correlation is, but now we're going to introduce causation. So what is correlation? So in this box, let's define correlation. It is our relationship between two things or two events. All right, so as X is changing, what's Y doing? All right, so it's our relationship between two events. Causation, so think about that, causes. One event causes or makes the other event happen. All right, so one thing causes the other. So one event makes the other thing happen. So correlation, there's a relationship, right? There's a relationship that exists between the two things that you're looking at. Causation, one thing is a direct result of the other. All right, now it is important to realize that correlation, just because it's a relationship, it doesn't mean that it causes the other thing to happen. And we're going to go through some examples of that. So let's take a look at this first example. How are these things correlated? So how are they related to one another? Okay, so hours of sleep and tiredness. I'm more tired, so there's a negative correlation. We can just see from the graph, right? There's a negative correlation, right? Because it's going down, a negative linear correlation. So this is a negative. All right, there's a negative correlation. All right, because as one thing is increasing, I'm more tired, the less hours of sleep I get. I'm going to say it again. The more tired I am, as X is increasing, the less hours of sleep I have. Okay, yes. If I have less hours of sleep, it is true that I will be more tired. Okay, so as Y is decreasing, X is increasing. All right, so now the question becomes, so I know there's a relationship, there's a negative correlation, but does one thing cause the other? So if I don't sleep, am I going to be tired? Yes. All right. And that's the reason, right? So in general, and again, these are always, let me write this in general. So there's some people maybe who they sleep less and they're not tired somehow. But in general, for the population, right? Again, the less I sleep, the more tired I am. The less I sleep, the more tired I am. So again, correlation is just a relationship between the two, but one thing doesn't cause the other. But sometimes something is correlated and it's also causation. Okay, so let's look at another example. How are these two things correlated? All right, so again, what's the relationship between height and weight? According to this graph, there is a positive correlation. Okay, there's a positive correlation. Now the question is, just because they're correlated, just because there's a relationship between height and weight for this data set, does one thing cause the other? So let's look at it. Does the more, okay, I'll do X. The more I weigh cause me to be taller. The more I weigh, so as X is increasing, my height is also increasing. So the more I weigh, I'm taller? No. And why is that? Because weight does not influence my height. All right, so again, it's very, very important to realize correlation, a relationship, doesn't necessarily mean there's a causation. Just because there's a relationship doesn't mean one thing causes the other. All right, so again, sometimes it does, but sometimes it doesn't. So it doesn't necessarily mean that the other thing is going to be affected. Okay, now what we're going to do is going to practice this. And again, remember the key word is in general. Okay, in general. So yes, there are exceptions, there are things that will fall into both, but in general, for the most of the population. Let's do a couple of questions. Okay. All right, so the number of cars traveling over a busy holiday weekend and the number of accidents reported. So again, does more cars on a weekend mean more accidents? So basically, if we're all traveling for Christmas, does that mean we're going to get into an accident? No. So this is not causation. More cars on the road doesn't mean that I'm going to get into an accident. However, Is it related? Yes. Maybe there might be some more accidents. Maybe there won't be. Okay, so this one is a correlation, not a causation. There is a relationship. The chances are you may get into an accident, but it doesn't necessarily cause the accident. All right. How about the number of cars a salesperson sells and how much commission he makes? Okay, so you may not know this, but generally salespeople make commission based on what they sell. So if I, as I'm a salesperson, if I sell more cars, yes, I make more commission. So this is causation because this more I sell causes my money to increase. So this one is causation. All right. The increase of warm, sunny days and the number of ice cream vendors visible. Okay, so yeah, you see the ice cream people outside, right? But does that mean you don't see them when it's cold? No, right? So just because it's sunny outside, it doesn't make the ice cream people be like, oh, I'm gonna be outside. It doesn't do that. But there is a relationship because they still sell ice cream during the winter, right? But there is a relationship that exists to that. So this is also a causation. A correlation, sorry. I'm going to just join that arrow to the correlation. The number of miles driven and the amount of gas. All right, so does the number of miles I drive mean my gas is affected? Absolutely, because how else I guess nowadays we do have electric cars. Let me just assume that we're talking about gas cars. Okay, so for this example, we're talking about gas cars. The number of miles driven in a gas car, I guess we're going to add that, in a gas car. Okay, the number of miles driven in a gas car and the amount of gas used. Yes, if I drive more, it causes my gas to go down. So this one is a causation. Okay, so I'm just going to join the arrow. I'll do one more and then you can do the rest. The season of the year and the number of water-related injuries or deaths. Is that correlation or causation? All right, so does the season, so let's say it's a season to be in the water, does that cause injuries and death? No, so it's not causation, so therefore it's correlation. All right, so go ahead and do these three, and then you're going to show me. So pause the video and do those three. The last thing we're going to look at is the line of best fit. All this means is, and I kind of mentioned it in a previous video, is split the data, okay? So what you're going to do is, so we did it as a sketch before, but if this is a question that's asked, what you would really need to do is you would input all the data into Desmos. It's going to give you a picture. So these are dots, okay? Now, I've gone over a couple, I've gone over this. This is a positive correlation, right? Now, we are going to be a little bit more specific. This is a positive linear relationship. So if I see the scatter plot, the scatter dots look like this, I know to type in, all right? So make sure your table is labeled. If it's linear, quadratic, or exponential, I know this one looks linear, so I would type in y1 squiggly line mx1 plus b. And then I would look for my m, which is my slope, and my b, which is my y-intercept. And then I'll plug it in, so that would be my equation. And that would be the line of best fit. If I input all the set of points into Desmos, and it looks like this shape, what shape would that look like? Well, that shape would look like a quadratic. So what do you think I would put in? If it looks like a quadratic, then I would use the equation for a quadratic. And again, this is all in your formula sheet. Okay. And then once I find my A, B, and C, that would be, I plug it into the formula where I see A, B, and C. All right. So go ahead and you do this last one. What does that shape look like? Do a line of best fit for me. And then just draw an arrow to what this would be. Let's practice.